The aim of this project is to build a tool which allows you to put in a set of spatial data and non-spatial variables to interrogate or identify and interrogate Melbourne metropolitan employment clusters. This comes out of some thinking that Jenny and I became involved in after I had started doing some work actually on Dandenong, looking at or trying to think about how would you know how effective clustering policies, which have been around since at least the 1950s, had been in Melbourne, and whether or not there was any evidence to suggest that clustering policies A cause clustering and B cause anything like the sorts of outcomes that they were purporting to create. So obviously clustering policies have been about bringing jobs closer to where people live, dealing with congestion in the city, creating economic advantage through agglomeration economies, creating alive places which increase street activity and therefore safety, reduce inequality in terms of access to jobs and economic disadvantage, or create economic advantage in areas which are disadvantaged, all of which are issues for the northwest area. Now, to make a study of that kind of nature, one of the things you need to be able to do is find an independent tool that found where economic clusters exist, and then once you knew that, you need some kind of connection to the sorts of data that we can get from the ABS and other places about the nature of jobs in those clusters, the people who live around those clusters, whether the people who live in those clusters are the ones coming to work there, and so on. So that we were looking for seemed to be a very good snug fit with the Oren Ann's project, because it brings together those kinds of different data sets. And as a first step, what we're doing is trying to develop a tool which uses employment data as a proxy for business activity. Now that's because in Australia, unlike some other places in the world, many other places in the world, you can't get economic data on the output, turnover and functioning of businesses, and therefore if you want to know about economic activity, what you do is use jobs as a proxy. Of course, jobs don't necessarily tell you about economic clusters, because some economic activity happens at quite high levels with quite small numbers of employees, but it works as a proxy and as a first step. So the plan is that the tool will provide immediate information on the industry employment clusters that might exist in the Northwest Corridor, and whether or not sector-specific clusters have emerged, and where they are, the nature and type of jobs that are in those clusters at a finer spatial unit than the ABS destination zones. ABS destination zones are quite large objects, especially as you get further away from the metropolitan centre. And they also have a number of other issues which we'll go into in a moment. And also, hopefully, we're looking to get access to information on key service workers and how they're interacting with whatever economic clusters we may find. The benefits of that are that once we have the tool working, we'll be able to upload numerous different data sets that are available from previous census data and will become available in the future to analyse clusters and where they are and how they've emerged over time, which we would like to use to analyse whether or not clustering policy has had an effect on whatever clusters have actually emerged. This arises out of some questions that were asked about the efficacy of government policy, which is designed to make businesses do things, and whether or not there's any real connection between those two things. There's also the opportunity to make comparisons then of the situation of the clusters we find with central activity districts or centres with places which are not clustered, and the types of accessibility to jobs that are available in those different places. So, elements of the tool. The tool starts with a clustering algorithm. Clustering algorithms usually operate using a key non-spatial variable and adjacency to work out whether or not something should be included, a polygon should be included in this grouping or not. Now, there's a couple of issues with that, one of which is that you only have one variable, you can't use multiple variables, and the other is that it's based on adjacency rather than, so the polygons have to be touching in some way in order to join. Now, we've made a couple of advancements, we hope, on that theory. The first is we've expanded the algorithm by allowing a polygon dissimilarity function, which will allow for multivariate clustering on multiple different non-spatial attributes like jobs and female employment and whatever else you might want to add into that kind of a multivariate analysis. It also will allow a distance function which can be a spatial distance function which can be adjusted to allow for non-adjacency. So polygons which are not directly connected can become part of a cluster in a theoretical model that uses the non-spatial distance to think about. So if you're thinking about the difference between two polygons and the number of jobs, the difference might be one has 7 and one has 6, but they might have a big spatial gap between them, in which case they might still be a cluster, they just might have a series of residential houses in between them. That of course depends on your theoretical model about how close something has to be physically in order to be part of a cluster. We've also will undertake a value chain analysis looking at using published economic data to think at the ANZIC code level to think about what kinds of value chains exist in the Victorian economic context, and that will allow for clusters to be developed on specific industries which might not be as obvious as they seem. So for example, it may be that you could say that in Broadmeadows the cluster around automotive industry also includes a series of plastic manufacturers and storage facilities, trucking agencies, etc., which otherwise wouldn't necessarily sit within what's called mobility in an ANZIC code sense. And finally, we're going to allow, as I said, we want to split the DZN zones, or the destination zones, because they're quite large, and they also generally contain both bits of them which have jobs in them and bits of them which don't. So we're creating a way to parse the spatial data that we have using the value generals data, and I'll explain that in a moment. So the clustering algorithm, as I said, works on both Euclidean distance and non-spatial attributes. So for example, if we're talking about clusters of jobs, we're interested in building a spatial grouping of related jobs and knowing where the boundaries of that spatial grouping is. So if we had polygons that look like, for example, like that, the first thing the algorithm will do is remove any polygons which don't have any jobs, like that. And then once it's done that, it then starts to calculate the distance between every polygon and all the other polygons in terms of both the physical distance between them and the non-spatial distance. So for example, it will take the two closest ones and merge them, and then recalculate the distance between the merged and all the others, and take that data, figure out which ones are closest, and make the next polygons merge, and it continues to build like that until you get these kind of clusters, and eventually everything is joined up. So you can either, in the tool, either set the clusters so that it stops at, say, 3, or you can let it run until the end, and then inductively look back at the data until you decide what is a sensible place at which to decide these clusters work. So for example, in the next iteration of the clustering model, it might add this cluster, but this cluster, this polygon might only have one job, and you might decide that at this point, the adding of more of these polygons, even though they do have one job in them, isn't actually going to add value to your understanding of the cluster, the geographical location of the cluster. I said I would tell you a bit more about how we're going to pass the data up. Our plan with dividing up the destination zones is to use the value of generals data and bitmap data on both government buildings and parks and so on, and zoning to split up the destination zone. So if the blue line is the destination zone outline, what we'll do is lay over that the zoning and identify government or non-commercial organisations which might have jobs in them using bitmap, and then look at the zoned areas that are zoned commercial and use the value of generals data to check that those zones actually have commercial activity in them and where the boundary of that is. And having identified those zones, we'll then ask the computer to allocate jobs that are allocated to the entire DZ to those specific areas according to the job codes that are in the data. So this will allow, obviously, the creation of non-contiguous polygons and the removal of the bits of the environment which are not having jobs in them. Progress to date, the algorithm is, progress is underway. We've almost finished that. We're working with Aura to get it up onto the portal in some form. It needs to be encased in its Java to make it able to be read by that system. We've obtained the data sets we need in order to run a test. Sorry, my brain just lost that word. So yes, so in order to run an exemplar of the system, it's working with sufficient data to do that. We're working on trying to access some historical data so that we can start to do some of this research work that we're interested in of examining clustering policy over time. We're working on designing the user interface, and we've been constantly thinking about this question of how we could interact with the need to try and get some better economic data made available so we can actually assess this economic and vulnerability effect of clustering. That's probably a long-term project. So yeah.